Well, let's see. I hired a freshman last summer, and that's kind of what got us thinking about doing something like this. And I was actually surprised at how much that student was able to do, because many of us, certainly I had the opinion that freshmen don't have enough skills under their control to actually be productive in the lab, and that's clearly not true. And I learned this last summer. So I do semiconductor device research. I'm on the opposite spectrum as far as what you've just heard about. But there's a lot of activity in semiconductor devices for, well, let's see. The semiconductors I work on compared to silicon are considered exotic. They're much more expensive than silicon. But most of my work is using gallium nitride. It's a wide bandgap semiconductor, and it's the same material that's used to make the green, blue, and white LEDs that you see all over the place. It's also the red and orange LEDs are made by another material. But gallium nitride has produced efficient LEDs in that important portion of the visible spectrum, and it's now to the point that LEDs are getting ready to take over the general lighting market. And when that happens, there'll be more semiconductors in that one application for lighting sold. There'll be more semiconductors processed, more wafers than all other applications combined. So it's a big thing. And so right now there's several U.S. corporations that are gearing up to use gallium nitride for power electronics. It's very suitable for that. It's also suitable for very high frequency, high power electronics. So in the power electronics area, there's the low frequency stuff, and this is something as simple as making a DC power supply to drive LEDs, because LEDs are going to be everywhere. But your run-of-the-mill DC power supply that's reasonably inexpensive is only about 70% efficient. So with exotic transistors in a switching power supply design, you can push the efficiency up to 99+%. So people feel that there will be a huge application for gallium nitride electronics to drive gallium nitride LEDs when the LEDs penetrate the lighting market. So the other thing that these devices do, I mentioned, they can operate at very high power at very high frequency. So we have transistors we've developed that have bandwidths of 300 gigahertz that are able to support over 150 volt voltage swings at that frequency. So I'm collaborating with another faculty member who is a circuit designer, and we're trying to build the world's first harmonic oscillators at 1 terahertz. And in doing that, there'll be terahertz sources. This is a range of the spectrum that's between electronics and infrared light. It's, for the most part, not been accessible to man. And now it's, in the next 5 to 10 years, there'll probably be 100 milliwatt terahertz sources available. And that'll be used for medical imaging. It'll also be used for surveillance, because there'll also be a new market for clothing. People will be sewing metal linings into clothes, because the terahertz camera that's sitting on the wall in the airport is going to look right through your clothes. It's going to look through, it sees through wood, concrete, plastics, cotton. So you got to wear a sheet of metal if you don't want people looking at the details of your body. So, but that's a big application. There's also a lot of really good medical applications for terahertz radiation. So that's going on with collaboration with another faculty member. But I do the crystal growth, the device fabrication. Cornell has probably the most advanced semiconductor fabrication facility of any university in the world. And so we have very exotic equipment to build very small-scale, nano-sized devices. And we also have a lab in Duffield where we have additional fabrication tools that the big center downstairs does not have. And when we combine all that together, we can run a gallium nitride fabrication process. for either transistors or light emitting diodes or whatever. So we built some high power transistors, and I set up a microwave measurement for those devices last summer, and the student came in and took an instrument which came from Agilent and wrote a driver so that instrument would integrate into this big measurement system. And that was successful, and that measurement's been running since that student did that work. So if you're interested in doing some software development for measurement automation, it's not quite as sophisticated as what these guys are talking about, but it sure saves a whole lot of work in the lab when you have the computers running the measurements. If you're interested in semiconductor fabrication, then you can come talk to me, and I can steer you to other faculty that are also doing this sort of thing if you want to get some hands-on experience with fabrication. So that would be a possibility. The other possibility is to help automate some measurements or even perform some measurements on some semiconductor devices. Okay? Any questions? Yeah.
I didn't get your name.
My name is Professor Shealy.
Shealy?
Yeah. Okay. So if you have any questions, anything peripheral to physical, I guess this is physical electronics as opposed to the other stuff you heard about. But this is a big, it's, I mean, we have, well, somebody had to create the reality that these guys play with. So in any case, if you have anything in physical electronics, you can come to me and ask about it, and I can steer you to other faculty members as well. Yeah.
Just out of curiosity, are there any like previous experiences or backgrounds that you would prefer for any students who are interested?
I don't know, if you can use, if you're handy with a screwdriver and a pair of pliers, because, you know, physical electronics requires physical stuff. You know, it's not just the tips of your fingers hitting keys. We build systems that we use to fabricate semiconductors. So if you had any lab experience, either electronic, has anybody in here? No, you haven't taken 2100 yet, of course. A course like that would be, if you have.
We're in it now.
Oh, good. That's good experience because you're getting a lab experience doing measurements, and that can carry on to you're learning about source measurement units. We use those in semiconductor. They were originally developed for semiconductor device testing.
Probably not required.
Not required, but if you have that kind of experience, it might help. But if you've had any exposure to doing some complex fabrication task, whether if it was an automobile transmission or something, it doesn't really matter. If you're good with your hands and you can kind of see the big picture and all the little pieces that get involved in making something work, then I think that is good experience that could help.